Evan's teaching class, Learning for Greater Heights. Please subscribe to our YouTube channel.
So good evening, guys. Welcome to my YouTube channel. So our topic today is dimension. So we have talked about fundamental quantities and units. We know more about them. That fundamental quantities are the quantities that does not depend on any other quantities, and fundamental units are the unit that does not depend on another unit. So let's do the main reason why we use fundamental quantities and units is because fundamental quantities, when you see them, they are independent. You can use them for your dimension. So what's the unit of mass? It is what? Kilogram. We are going to be using only three quantities: mass, length, and time. So wherever you see kilogram, that is kg, what starts mass? What starts the beginning of mass? You will see that it is m that starts mass. Whenever you see kilogram in your quantity or in your units, put m there when you are doing dimension. Also, whenever you see meter, when you see m, put l in the front of it because l begins length. Also, whenever you see seconds in doing dimension, or you see s, put t in the front of put c in place of s. So that's how you are going to be doing it. So now, what is the unit of acceleration? The unit of acceleration is meter per seconds squared. So now, m is meter, right? So here we are going to replace the m with what? With l. Put l there. Also, the seconds, the s, replace it with t. So let us put t there. Then let's go to velocity. What is the unit of velocity? Meter per seconds. Now let us replace it. When we see meter, what are we going to use? We're going to use L. Let us replace it with L. Also, seconds, what are we going to do? Replace it with T. So we are now done with velocity. That's that for dimension. Now let's go to the force. The unit of force is Newton. So we are not going to use Newton because Newton cannot be converted to a dimension. So now to do that, what we are going to do is that we know the formula of force to be mass times acceleration. Now to do it, we are going to firstly write the unit of mass. What is the unit of mass? Kilogram. Times, what is the unit of acceleration? Meter per second square. Meter per second square. So now, wherever we see kg, you know that we are supposed to put m there. Now we are going to put m wherever we see kg. Times, in the meter, put what? Put l there. So put l there. Wherever you see seconds, put what? Put t there. So that's that. So now multiply it. You're going to write the same thing. It's very simple. So that's it. Now let us go to pressure. Also, the unit of pressure is Newton per meter squared, or Newton per meter or Newton per meter square, or Pascal, or millimeter mercury, or centimeter mercury, and so on. But this is the main one we are going to be using. Here also, Newton is in the units. I want you to understand the principle. Newton is in the units, and we cannot split Newton because Newton is not part of these three main quantities that we are using. We are not going to use that Newton. What we are going to do is that we are going to split that Newton down so that we can have the opportunity to use that Newton, which is force. Newton there here represents force. So now we know that the formula for pressure is pressure is equals to force over area. Now, what is force? Mass times acceleration. What is the formula for area? In our mathematics, we always say area is length times breadth, right? Length times breadth. Or it can also be length times length at times. So now, what's the unit of our mass? The unit of our mass is kilogram. The unit of our acceleration is meter per seconds squared over. What is the unit of length? That's meter. What is the unit of breadth? Meter. So using mathematics method, meter cancel meter. Then you're going to say kilogram. Put this m according to mathematics. You know that kilogram times 1 over m times second square. I hope you understand using a mathematical method. So it will now be kilogram times per meter times seconds squared. So now, using our principle, wherever you see kilogram, put m there because it represents mass, right? Then meter, put L there per L. Seconds, put T there per T squared. So that's that for that one question. Let's go to density. Density, the unit of density is kilogram per meter cube. But what is the formula for density? Mass over volume. Mass over volume. What is the unit of mass? Kilogram. What is the unit of volume? We always know it that volume is meter cube. So now meter cube. So using our principle or using mathematics principle, if you want to take this meter cube, is the denominator, right? To bring the meter cube up, what you are going to do is that you are going to make minus come to this place as a rule of indices, because 1 over a is equals to a raised power minus 1. I hope you understand. 1 over a squared is equals to a raised to power minus 2. So now let's use that principle. So now it will now become kilogram per meter cube. Using our principle, whenever you see kg, put m there. Put m. Wherever you see meter per meter cube, put L there. So that's that for our dimension. So let's go to work. Let's go to work. Work is equals to force times distance. We don't need to waste our time. We already know the formula for the unit of force using this method. So we can input it directly without wasting time. Kilogram, I hope you understand, times, what is the unit of distance? The unit of distance is meter. So let's put it there. So now, let's multiply it first. It will now become kilogram, m times m, meter squared, then per s squared. Then you're going to say, wherever you see kilogram, put m there, because it represents mass. Wherever you see meter squared, put L there, because it represents length. Wherever you see seconds, S, put T there. So that will be minus 2. That's that. Then let us go to moments. Moments is the same thing as work, so we don't need to waste our time. The formula for moment is force times perpendicular height. Perpendicular height. I hope you understand. And height is the same thing as distance. I want you to understand the concept. Height is the same thing as distance, because in terms of units, they have the same units. So we don't force and perpendicular height and distance, they have the same units. And force also is in this place. So we don't need to waste our time. The unit for for the dimension for moment is ml squared. So we're going to bring this one and write it there. Then let's go to the impulse. So impulse is equals to force times time. Here also, what we don't like is still there. We are not going to use force. I have told you in the beginning that we are not going to use force when force is is part of the formula. So what we are going to do now is that we're going to split force again, but because we know the unit of force directly, let's bring it there because of our time. Kilogram per meter squared times, what is the unit of time? Seconds. Now let's multiply it. Seconds, let's say this one is s raised power 1, right? Using law of indices, let me explain it to you. You are going to take a single base, right? Take a single base. So it will now be s raised power minus 2 plus 1. You are going to add because it's a multiplication. So it will now become s raised power minus 1. So let's go here. It will now be kilogram meter per. So it will remain 1. Let me write it that way. Kilogram meter then per seconds. So that's that. That's the unit for, or you can write it this way. Don't let me confuse you guys. Kilogram meter per seconds. Don't be confused with this per, because when you put minus 1 on the top here, you are not going to put any slash, or divide. You're not going to put any divide. But when we don't put minus 1, we are going to put divide, just like meter per second squared. Look at this one. If I want to rewrite it, or meter per second squared. I hope you understand. So that's that. So let's go to momentum. But I want you to know momentum also is equals to impulse. Ask me why. So why? So from the formula, F is equals to m into v minus u over t. You will notice that Ft is equals to mv minus u. What's the meaning of, what's momentum? Momentum is the product of mass and velocity, which means this is already what? This is already momentum. So it means momentum is equals to impulse. So our dimension will now be, what do we get for impulse? So let's come back there. What do we get for impulse? Okay, we have not finalized it. Let's put what we normally do. Wherever you see kg, put m there. Wherever you see meter, put L there. Wherever you see s, put t there. So now we are through. So that's that. So let us input the same thing for this one. So ml per t. So let's go to energy. So energy also, it has the same unit as, the same dimension as, the same unit as work, the same dimension as work. So what is our dimension for our work? So let's go there. Work, our dimension, ml squared per t squared. So let's go there. ml squared per t squared. We already know the unit of area, so I just write it there. I just wrote it there. Meter squared, unit of volume, meter cube. So what will the dimension of meter squared be now? It will now be L squared. It will now be L cube. Thank you for watching this video. Please subscribe to my YouTube channel.